create a function that has the set from -infinity to -7 inclusive, union 6 exclusive to positive infinity as the domain. Use closed dots to include the point. Use open dots, closed dots at the end of line segments or arrays to signify the endpoint is excluded or included. Any open dot not associated with the end of array or line segment will cause the graph to be treated as not a function. Okay, so any function that would have these particular x values as its domain is all we're really looking like for. There's a lot of different options here. So effectively what we need to make sure of is the x value -7 is included in the set. So I'm going to start off there and put a closed circle somewhere -7. And it in fact doesn't matter. As long as it's on the x value -7, it's fine. So here I'll just randomly throw it at 3. And then I need to include the value 6 as an open circle because it's a parentheses and not a bracket. So 6 as an open circle, I just need to put it somewhere in the y because this point is associated with 6 somewhere in the y. It doesn't matter where in the y. In fact, I could even just put it right on the x-axis and it wouldn't make any difference at all. Now the rest of the domain, it has to be something going from -infinity up to -7, and then also later on from 6 to positive infinity. That's where the line and segment tools are going to come into play. And in fact, I'm sorry, this is actually array. So I'm going to use the ray because I need this to go to infinity. So for instance, if I have a set of values whose domain is -infinity up to -7, then what I'm going to do is create an array, and this could be a horizontal line, it could be an oblique line, it doesn't make any difference in the world because this particular line that I've drawn would have a domain from -infinity to -7 including. Then likewise, if I make an array for this particular part, so I could put this anywhere. It doesn't make any difference. As long as I don't do a vertical line or go back this way, then it's fine because this particular line here, for instance, its domain is starting from 6, but remember I had that as an open circle. And we don't see the open circle right now. Don't worry, it didn't get filled in. If you click the circle tool, you'll see that it's still an open circle. But all of these points are part of the domain of this graph, which is from 6 to positive infinity, just like what's requested. So now if we submit this, it will in fact give us the correct values. And as I said, there's lots of different ways of doing this. So we could have had, this point, we could have had just the line. Just do it along the x-axis. If you get in a situation like this where you have a line and you need to get rid of it, you can click outside of the graph and it'll close that out. And then from 6 to positive infinity, I can do it this way and just do horizontal lines on the x-axis. And that still qualifies as a function whose domain is this right here.